-1. Yeah, it looks something like this. It kind of comes up and then curves and does some stuff. I think it looks something like that, if I remember correctly. So here's what you need to know. Area in the, oh man, is that irritating. So I'd have to split it into two zones. Either way you split this, you're gonna get two. So I would say on my calculator, figure out what that point is by finding a root. I think it is points, hang on, 0.7 some change. Yeah, okay. So it is 0.739 and some change. And then this place where these two meet is at 1.85, can't read my writing, 8, ... And then there's a y value, but I don't really care about that. So you need to set this up in two integrals. Let's call that A, let's call that B. You would need to, in your calculator, go from 0 to A of nothing but the line, because the cosine isn't even involved there, and get that answer. And then your second piece would have to go from A to B, whatever that is, of line on top and x minus cosine on the bottom. So it looks a little nasty, but your calculator would do the work for you, and I think you get 4.54-ish. All right. The region R, or let R be the region in the first quadrant enclosed by the lines x equals natural log of 3, y equals 1, and y equals e to the x over 2. The volume of the solid when we revolve it. Okay, here's how we're going to set this one up. You have, what does that look like? Okay, you'll have this set up here. You got y equals 1, you got y equals e to the x over 2, which does something like that, and you got natural log of 3, which I think is a number that's reminiscent of the quiz. I think I had one on the quiz that was similar to that. Different function, but something like that. And we're revolving this around the line y equals -1. Okay. So this one's going to be washer. My volume will be pi from 0 to natural log of 3. 0 to natural log of 3. Top function is going to be this distance right here, which is going to be the e function plus an extra 1. So the e to the x over 2 plus 1 squared. Inside radius is just going to be a flat 2 all the way through 2 squared. And that would be what I would plug into my calculator, and it gives me an answer that is approximately 5.128. Okay, I missed a 1 there. There we go. Pretty straightforward on that one. Don't forget the pi and yada yada yada. Number 8. Oh, number 8. So we have f of x equals natural log of e to the x squared. By the way, did anybody do the same thing I did? Y'all see the natural log and the e cancel each other out? You could have just rewritten this as y equals x squared, which is what I did. It's easier to do that way. Find the average value of the function on the interval from 0 to 3. Sweet, I think average value in my sleep. All right, 1 over b minus, what is my interval? 3? 3 minus 0. Interval from 0 to 3 of x squared dx. Again, type in your calculator if you want to, but this one is just as easy to do without it. That's going to be 1/3 times 1/3 x cubed from 0 to 3, which is 1/9 times 27 minus 0. 27 divided by 9 is 3. question 9, find the total area, man do I love total area, bounded by the graph of the curve and the x-axis. Okay, so you need to know where this graph crosses the x-axis to know where to cut the interval. So for number, that was 3. For number 4, first thing I would do is set x cubed minus 5x squared plus 4x equal to 0. Now on your calculator, you could have just graphed it and found the roots. That's nothing too terribly out of the ordinary. You can factor this, however. That will be x, x minus 4, and x minus 1, which gives you 3 roots at 0, 1, and 4. I don't really, okay, if you're doing it by hand, you need to do it in 2 pieces. You need to do the 0 to 1 chunk and the 1 to 4 chunk. However, because we've got a calculator, it is just as easy to do this. Go ahead and just slap an absolute value around the end of it, and then plug the whole thing in your calculator in one step. All right, that's probably the nicest. 11.83. All right, so there was 6, 7, here I am numbering them badly, that was 7, it was 8, and that was 9. Okay. Take a little breather there, let you gather your thoughts. Everybody cool on 6, 7, 8, 9? Then we get to 10. Let the region in the first quadrant bounded by the root of x and the lines y equals 0 and y equals 4 is revolved about the x-axis. By the way, we've done this very same problem, I think, in class. I honestly think we have done this exact same problem in class. Let's see what number 10 looks like. The region we're discussing is this. That's that, and we're rotating it around the x-axis. Ooh, but then they say, if a plane perpendicular to the x-axis at the point x equals k, so something x equals k, divides the solid into parts of equal volume. Sweet. So the first thing I need to do is figure out what the whole volume is. Let's see, it's a disk, so the volume is going to be pi from 0 to 4 of r squared, square root of x squared. That's lovely. 0 to 4 of just good old x. Antiderivative is going to be 1/2 x squared, so we're going to get pi halves x squared from 0 to 4, which gives us 4 squared is 16, half of that is 8, so 8 pi minus 0, or 8 pi. So what I need to do is this. I need to do the same volume, pi from 0, but we're going to stop at k, from 0 to k, of that. Okay, that's right here, that's squared, dx, and I need that answer to be 4 pi, half of whatever the volume is. That's relatively simple. This is going to be pi over 2 x squared from 0 to k will equal 4 pi. You do a lot of stuff right here. I'm going to go ahead and do this. The pi's will cancel out, multiply by 2, so I get x squared from 0 to k is going to equal 8. If you actually evaluate this, you'll get k squared minus 0 equals 8. So we get k squared equals 8, and k is whatever the square root of 8 is, which they put as 2.83. Love it. All right, we'll pause there. Everybody good? Then we get to the last question, which, oh man, there are laws in place for this reason. I wish I could say what I was actually thinking about this last free response question. I mean, I'm going to tell you how disappointed I am, but my tongue is tied. Let R, this is number 2, let R be the region bounded by the graph of y equals square root of x, y equals e to the negative 3x, and the vertical line x equals 1. All right. Does that look familiar to anybody? Aside from having seen this problem on the actual test yesterday, does this look familiar to you? This was your quest question. This is one of your 6 quest questions.
I know.
Verbatim, okay?
Whenever I was gonna do it, I was going.
It was the exact same question. And y'all did a good job on the quest, but then somehow flubbed it up on the actual test. So I'll go ahead and do it now, and I will not do it again when we go over the quest, but there it is. Find the area of R. Okay, so you have this picture. You've got square root of x doing something like this. And then you have e to the negative 3x doing something like this. And then you have x equals 1 cutting through somewhere over here. So this is the area in question. Right there. X equals 1, y equals e to the negative 3x, and y equals square root of x. Find the area of R. So the first thing I have to do is figure out what this point of intersection is. It is 0.238 and some change, comma, whatever the y value is. I don't really care. I can't remember what it is. Whatever. So for area, I'm going to go, I'll call that A. Big A. For the area, I'm going to go from A, because that's where they started, to 1, that's where they artificially stopped me. Top function minus bottom function. All right, there's your setup. Written exactly like that, plug it in the calculator. You can do this with my hand. It's not gonna look, I mean, you're gonna have an E in the answer, and we can't really evaluate that. So I go straight to the calculator, and it tells me 0.442. And some change, 442, 443, something like that. I think it did round up to 3. All right, part B. Find the volume of the solid when R is revolved around the line y equals 1. Okay, here's y equals 1 right here. So this is the line they want me to go around for part B. That is washer. And your inside and outside radii are going to look like this. From the line, the farthest point is here. That's my outside radius. And the shortest point is here. That's my inside radius. So, washer. Pi from A to 1. Okay, outside radius. Outside radius is going to be 1 minus the E. That's going to be what's left over. So 1 minus the E thing squared, pi r squared, minus inside radius, which is 1 minus the root squared. There's the setup, and then our final answer for that one is somewhere in the neighborhood of 1.424. Okay? And then we have part C. We're going to create rectangles, cross-sectional rectangles perpendicular to the x-axis. They're going to be 5 times the length, 5 times the height as the base. Okay. So area of rectangle is length times width, or in this case, I'm going to write base times height. Let's see here. The base of it is just going to be this distance right here. Okay, that's the base right there. So the base will be the root minus the E, and the height is going to be 5 times that. So the area in terms of x is going to be 5 that squared, base times height. All right, so my volume is going to be 5 integral from a to 1 of that. There you go. So I will not recreate that one as we go over the free response, because there it is, exact same question from free response. Any follow-up questions? Feel good? Sweet, okay. Put those in a safe place. Like I said, the scores were not stellar by any stretch of the imagination, but you were all kind of on the same, consistently messing it up, okay? Which is why the grades came out as tight as they did. And poor old Michael just knocked the friggin' top off of it, so everybody else's scores kind of clustered around 90. It was really close to 90. If you have one person scoring super high, you have a 99 and then a whole lot of kind of 90s. If you have one poor person scoring consistently low, just one scored low, but everybody else is the same, then you have a whole lot of scores around 90, or actually higher, a whole lot of scores around 95, 98, and then that one score that's just low, low. All right. And now let's go over free responses. All right, I have raw scores on them. I do not have finished scores because I need to finish grading Chelsea's, but you just look over it as we go over this. Raymond Amber. And I'm hoping that we can zip through this super fast because I think y'all overall did a much, I mean, giving you a week and you have time to talk and time to think about it, you'll seem to do well. How are y'all collaborating? Do y'all actually get together and swap numbers and chit chat on these, or do y'all just kind of work on your own? And then maybe the last day you ask everybody what you got? What do you get for number? Y'all don't network? Get on your little, can I talk about this on Facebook? Really? Hey, what'd you get for nothing?
That'd be hard to type in.
Just take pictures of it and
Yeah.
pin it, whatever y'all do this. Or Snapchat it, you got 10 seconds to memorize it, and then it's gone forever. All
That'd be
right.
something Michael would do.
Yeah.
It'd be like the longest one.
All right, let's see. This one was calculator, so we could use calculator on it. For the first one, you have this shaded region. Let's see, a good old parabola and a horizontal line. Okay, figure not drawn to scale. I think it went from, this is y equals 4, y equals x squared, which means they would have hit at 2 and negative 2. All right. Part A, find the area of R. Okay, it is calculator, so I'm just gonna fast forward to the antiderivatives and leave that to you. Two ways to do this one, either go from negative 2 to 2 of the top function, which is 4, minus the bottom function, which is x squared, or go from 0 to 2 and double it because it's symmetric. Don't get in the habit of doing this and then use it incorrectly. It only works when you have a symmetric space. I think y'all are smart enough to know that. The right answer for this one is, if you did it all by hand, you would have gotten 32/3. If you plugged in your calculator, you would have gotten 10.6 repeating, or 10.667 if you rounded it off there. Any questions on that first one? If you can set it up, you can do the rest of it. Part B, find the volume of the solid generated when R is revolved around the x-axis. Again, classic. This one is washer. So, either from negative 2 to 2 or from 0 to 2 and double it. I'll leave it up to you again to do that. Outside radius, which is 4 squared minus inside radius, which is x squared, squared. You could have also cleaned that up to look like this. Alright, and the answer for that would have been, if you did it without a calculator, you get 256 pi over 5. If you use the calculator, you got 160.850. Okay? And I'm just gonna write these down until y'all say stop, because if you get it and you're following along, great. If you need me to go back and talk about it, then just stop me. Part C. Okay, this is where it got fun. There exists a number k somewhere between 0 and 4, or somewhere bigger than 4, so that when you revolve that region R about that line, so instead of spinning it this way, if we were to spin it this way, we get the exact same volume as if we had spun it this way. Write, but do not solve an equation involving an integral expression that can be used to find the value of k. So I'm going to imagine this line up here at y equals k, and that's what I'm going to spin it around. Pretty straightforward. It's going to be a washer with this being your outside radius and this being your inside radius. Alright, so pi from -2 to 2, or 0 and doubled again. Outside radius will be k minus x squared, minus the inside radius, which is going to be k minus 4 squared. There's half of it. That is the volume created. Now what I need is for that volume to be the same as the answer in B. So then I would take this and set it equal to whatever I got for my answer. And this is where you can still get points if you were wrong in B. As long as you set it equal to whatever answer you got in B, you were perfectly fine, assuming it wasn't negative. They didn't ask you to solve for it, it's just the setup for that. All right, any questions? All right, give you a moment to take whatever notes you need to, make any corrections. I think overall in this first one, as I was grading the quest, this one was a really good one. This was a high scoring quest question for those that did it. I don't know why you wouldn't, because it's super easy points. All right, erasing number 1. Number 2. Okay, I'm going to ask you to refer to your data, okay? It says, use the data from the table to find an approximation for W prime of 12. Show the work that leads to your answer and indicate units of measure. Thankfully, not a lot of y'all lost the points for in units of measure, but here's why they say show your work. W prime for us means derivative, but in its most primitive definition, it means slope. So we don't have a slope at 12, but we can kind of fake one. One of 3 ways. Either use the point 9 and 12 to do an underestimate, use the point 12 and 15 to do an overestimate, or do 9 and 15 and hope that it falls somewhere in the middle. So you could have done one of 3. I think one person, might have been Michael, did all 3 just for funsies. You only needed to do one of them. So I'm going to choose to split the difference. I'm going to say W prime of 12 is going to be approximately equal to, I'm going to use either side. I'm going to do W of 15 minus W of 9 over 15 minus 9. And just kick my slope old school. This is algebra 1 slope. All right, pulling these numbers straight off the chart, 15 would be 21, and 9 would be 24. And then 15 and 9, so we get, what is that, -3 over 6, or -1/2. The units would be degrees Celsius per day. It is a derivative, so it needs to be something per something else. That is one of three acceptable answers. If you had done the low end, 12 and 9, you would have got negative 2/3. And if you had done the higher numbers, 12 and 15, you would have gotten negative 1/3. And they're all kind of in the same neighborhood. Okay, approximate, that part B, approximate the average temperature in degrees Celsius of the water over the thing using 0 to 15 using trapezoids. Okay. If you're going online, this is the number one reason I can tell y'all are cheating, which you didn't. If you're going online, they actually use the formula for the trapezoid rule, which I have not taught you. I just teach you to average the left and the right. All right. So let's see. I'm going to do left. Okay, if we're using 3 days, that's going to be 1, 2, 3, 4, 5. We're going to have 5 different numbers. So I'm going to do L5. All right, that's a width of 3, and the 5 left numbers are 20, 31, 28, 24, and 22. And I'm pulling that straight off the chart again. If we do right, you will get, okay, the 31, the 28, the 24, the 22, and then the extra right one is 21. Okay, so if you get those two answers, and then whatever they are, and then average them together, I'll leave that work to you, ... you will get 376.5. Okay, I believe that is, yeah, 376.5. Then to do the average value part of it, find the average temperature. Well, that's our total. It's like us doing the interval from A to B and getting the total area, and then we need to divide that by the interval. So we need to do 1/15, because they said we were going from 0 to 15, of 376.5, which turns out to be 25.1. Okay? Again, if you're looking online or looking for something else, they would have used the formula for trapezoid, which isn't really that hard to figure out. But I just think it's one less formula for you to worry about. And this is pretty easy. Part C, a student proposes that the function P can be used as a model for the temperature of the water, okay? So that P of T could probably represent W of T. Find P prime of 12. Well, this is a joke. I'd plug it straight into my calculator. I wouldn't even bother trying to take a derivative. Y'all know how to do math 8 to take a derivative on that one. So P prime of 12 from the calculator is just going to be negative 0.549. All right, it is a derivative, so it's going to be degrees Celsius per day. Then this is the part that not everybody got right. Using appropriate units, explain the meaning in terms of the temperature. You need to be talking about 2 different units. Number 1, the actual temperature, and number 2, the length, which is day. So I would say at time T equals 12, what are we at, seconds or minutes or days? Day. All right, at T equals 12 days. So there's me mentioning that, all right? The temperature is changing at a rate of negative 0.549 degrees Celsius per day. Or, if you don't want to use changing, you could also use the word decreasing or dropping. But if you do decreasing, you need to not include the negative, because that takes care of that in the wording. All right. Part D. Use the function p to find the average value. Okay, so average value. We would do from 1 over 15, 0 to 15 of whatever p of t is, dt. Plug it straight into the calculator and you get 25.757. Okay. Any questions on 2? Thought that one was pretty straightforward. All right, number 3. You know what? This one wasn't half bad. This is the one I could tell. Green Sea kids cheated on this one, by the way. Part D. Because none of them could explain what they wrote on their paper, and they wrote, I know what website they got it from too. Silly, silly children. All right, so without setting this one up, you have everything in your notes there. You got the picture of the graph, and then you have G, which is important. You have that G of X is going to be 5 plus the integral from 6 to X of F of T. And F is drawn for you. All right, part A. Find G of 6, G prime of 6, and G double prime of 6. Okay, this one's easy. G of 6 means plug 6 into this function, which means you're going to have 5 plus the integral from 6 to 6 of f of t. I couldn't care less what f of t is, because when you go from 6 to 6, that area is 0, so the answer is 5. Okay? G prime of 6 is the same thing as f of 6. This is a fundamental theorem question. I'm going to look at my picture, and f of 6 is up there at 3. G double prime of 6 is the same thing as f prime of 6, so I'm going to look at the slope at 6, which happens to be flat lined right there, so the slope is going to be 0. That was a quick and easy thank you for my 3 points. It really was. On what intervals is G decreasing? Again, super easy. We need to do, if we're going to do G decreasing, you need to know something about G prime. All right, G prime of x is equal to f of x. I need to know when G prime is negative, which means when is f negative? Looking at that picture, f is negative from, and here's where y'all screwed it up, -3 to 0, exclusive, onion, 12 to 15. Now the reason the -3 and the 15 are included is because they're included in the time interval and it's still technically negative there. The reason we don't use 0 and 12 is that's because it's at 0. Why? They said justify your answer because G prime of x or f of x is negative there. You don't need to say both. It's kind of nice if you do, because it shows the tie-in, the connection between the two. All right, C. Almost done. On what intervals is the graph of